Am I audible, ma'am?
Perfectly audible, sir. The screen is there.
Okay.
Yeah, kindly go ahead. Thank you.
So, good afternoon. I am Vijay Kumar Gandharaj. I am going to deliver a talk regarding melting point and lattice parameter dependency in gold and copper nanoparticles. So, my topic is divided into several sections, mainly outline, theory, resultant discussions, which consists two parts, melting point and lattice parameter, then conclusion and final references. So we start with this relation number one, it is purely theoretical standpoint. So this is alpha equals to 3.18 gamma d over d. This is here alpha is the ratio of surface atoms over total atoms in nanoparticles. Gamma is the shape factor, and d is the diameter of the material, and capital D is the diameter of the cluster. Actually, it is known to all of us that nanomaterials has some fascinating characteristics in contrast with its bulk material. Especially physical, if we think about physical parameters, then melting point lengths.
Sorry to interrupt you, Dr. Bijan.
Yes.
Your voice is not audible clearly. Please fix your mic.
Okay. Just a minute. Hello?
Yes, sir.
Okay.
Sir, there is no issue with the video because you're not audible clearly. This is the main issue. But just fix your mic.
So mic is mic is fixed. Okay. Fix your mic. Okay. Am I audible now?
Yes, sir.
Is it clear? Okay. Thank you. So, slide is visible? Slide is visible?
Yes,
Okay.
yes.
Thank you. So now, I just told you that nanomaterials have some fascinating characteristics, and in general, the lattice parameter, melting temperature, Bragg temperature, coordination number, everything gets reduced if we decrease the size of the nanoparticles. But surprisingly, specifically the nanoparticles increases with decreasing size of the nanoparticles. And also, shape factor plays a key role in determining such physical properties. And in this talk, this work, in fact, I will show the formula to evaluate the melting point and lattice time depression of nanomaterials of different size and shape. So let me start with this equation. So that is actually just now, alpha equals this one, where gamma is the shape factor, and alpha is the ratio between surface atoms and total aspiration. So in my previous paper, I have introduced an empirical relation relating the surface Bragg temperature and Bragg temperature like this, TdS over Td equals to exponential minus alpha by T. So we know that surface Bragg temperature or Bragg temperature is greater than melting temperature. So this formula can be extended in the form of Tmn over Tmb equals to the minus alpha. Putting the value of alpha, we have this equation. So this work is an extension of my previous work. That's all. So now, to justify our formula, we have to compare several theoretical predictions and experimental result. So with this paper, we have selected three results, theoretical results. One from Kayenra, second one is Alun Kai, and third one is Sefai. But interesting point is that there are three questions. All three questions finding temperature, melting point temperature nanoparticles and melting point temperature bioparticle ratio. But here's a delta factor. So this delta factor is relaxation factor. It is related to the binding them present in the nanomaterials. And in this equation, there is a Q. Q is nothing but Q is the ratio of the coordination number in surface atoms over the total atoms, coordination number. So, in order to find the change of lattice parameter, we have considered the surface energy model. And as surface energy is related to melting point, and it is evident that when we move from bulk to nanomaterials, surface energy increases. But due to contraction, due to surface stress, this increase of surface energy is to some extent reduced. And another energy that is common for the elastic energy. So adding these two energy and optimizing that, we can come to this relation. So that is very important relation. Epsilon equals to 1 over kd, where k is nothing but k is the g gamma to the power half over y1, g is the shear modulus, and gamma is the shape factor, and y is the surface energy of the nanomaterials. Here also, we are comparing two results. One from Pioneer, we arrive at the same expression, but from thermodynamical approach. What is that? That is actually y are similarly as an expression of bond energy. But Pioneer, they did this relation with surface tension thermodynamical approach. The relation was y equals to y0 plus some constant d by dt. So that is I have considered, and in general, actually my target or my focus is to find that change in lattice parameter. So this is the expression of lattice parameter, change in lattice parameter. This is the original lattice parameter of the bulk ratio. So this is epsilon, the shear strength. So 1 over 1 plus gy to the gamma over yn d. So my proposition, my formula, y equals to y into exponential, that is my, and another two I have shown. Between angle, y equals to 1 minus 2 d over d. And shear net, y equals to 1 minus 1.45 d over d. Identical. So now I got something resultant discussion. So in resultant discussion, this is my formula, and for gold and this for copper. And I have plotted the melting temperature of nanomaterials of different size and different shapes. Say I have taken 4 shapes, spherical with shape parameter smallest and cubical, tetrahedral, and nanofilm, for which I have taken shape factor as 3.09, considering Olympus height ratio 1 is to 10^1. So I find that the depression becomes greater when consider nanofilm structure, which means if stress factor is increased, as long as you increase the stress factor, the melting point will decrease. So, one that if stress factor increases to a very high, large value, then melting point stress leads to zero. It doesn't. It does not because some other factors comes in the picture. But suddenly, say, I mean, 1200 to 125 in fact. So that can be reduced to 300, 400 if we consider a nanofilm of high stress factor. And so, justify we have chosen an example for gold nanometer as 10 nanometer. In that case, our plot to this relevant measurement at 1 to 0.20 is identical with splendid value 1 to 2.5. And from equation 3, it is 1 to 2.1. And this is very important. This equation, I just want to slide back to the previous slide. This one. So this delta is a very important factor. This is very branching one. So gamma can be so that's not problem. But delta is relation of delta is not shiftable. So this person, this manipulated the value of delta to optimize the result. So that is very customary. So this result comes out to be overestimated. So analysis is happening. Result was just manipulation of delta. Delta is 0.25. Already, so model is my model where delta equals to 1 minus e to the power minus alpha over alpha. In that case, in our interstudy, alpha is this factor. So delta comes out to be this one. And in that case, delta comes out to be 1218, which is exactly equal to our result and which is very close to the experimental one. So, this relation will be very much helpful to use the Galilean representation. If only to use Galilean representation, then this formula may be usable too. So, this is the plotting between delta, that is Galilean represented, Galilean constant or relaxation factor is alpha, and this is experimental application. This solid line is our work, and this dotted line is the experimental value. So our result is within. For next parameter calculation, we have considered experimental value. For gold, this value, experimental value of size 3.5, 4.076 for 12.5, this is something like that. So our result finds good agreement. For nanofilm set, is a question. It's an interesting one. This draw, if I draw this one, this is drawn the figure for gold and copper separately. So find that. So this is experimental. And this is for spherical, this is for cubical, this is for tetrahedral, but this is for nanofilm. So nanofilm show almost experimental. And this result finds better agreement with other ones. So that is my approach. So after calculation is concerned, so the evaluation method is good again the external result. So our model can be used as a mathematical tool to find the reaction factor and relevant melting point for specific size and shape. And similarly for the next parameter, we find a good orbit agreement, and in fact, the nanometers with the nanofilm shape shows this agreement with the result. But one thing, one point I should mention here, that if we consider a nanometers a size less than 2 nanometer, that is very, very small, then this formula does not work properly. It will deviate to some extent. I think So this may be due to some temperature dependence parameter should be introduced in my original calculation. So that is my future program. So I'm trying to establish that, and I think, and when it will be, then it will be available. So I'm trying to do that because I strike out. It's not this body striking that some problem is there. So very small nanoparticle, but apart from that, more than 2 nanometer or 3 nanometers, this formula works very well up to a very high value. So these are differences.
Good afternoon to everyone. First of all, I would like to thank the organizer for giving me chance to deliver this talk. So myself, Dr. Chetan Chauhan, Department of Chemistry, Sardar Patel University, Mandi. The talk of my today's lecture is a novel spectrophotometric method for the rapid quantification of ostamere sulfate, that is OSP, using the dithiocarbamate complexation reaction. So basically, we are going to have a different time these days. We are now facing the corona. Similarly, there was one pandemic in 2009 that known to be a swine flu. So basically, the amine-based drug, which known to be a OSP, can be used as an antiviral medication for the treatment of this swine flu. So this was firstly reported in Mexico in 2009. And it has been occurring, reoccurring across the globe since 2009, in 2010, even in 2015. And many people have lost their lives because of this swine flu. So basically, this is caused by H1N1 subtype of influenza A, and it is used to be transmitted from the pigs into the human beings, and later on it transmitted from human to human. So it is going to be important because you can see from here that it has a direct impact on the respiratory system. And you can see there is a sudden onset of a fuel, cough, headache, and you have muscle pain across your body. And there is a different type of situation when you feel sore throat and running nose you can have when you suffer from such type of the flu. So this is going to be important, and you can see how the pig itself acts as a mixing vessel from which this virus used to transmit towards the human beings. And further, it can be problematic if it is not treated well in time. So it can be proved to be a fatal for the human beings. Although it is a normal fever for the pig, but when it transmits to the human system, it becomes fatal. So you can see the situation as per the WHO data sheet. There are lots of the death across the globe. So you can see the India is also impacted by this swine flu. So in view of this, there is a urgent need to have the treatment of this type of the flu. So we usually have various pharmaceutical companies that use to manufacture various formulations. So mostly we have been using so far two types of the formulation in Indian market. One is the Tamiflu, another is Star Flu. So it can be in the form of suspension, it can be in the form of the capsule. You can find in the market also. So this is basically a drug. This is an API of the drug which contain the amine group here. You can see from here. This is an amine-based drug. So having such type of the situation, just like pandemic, there is another market which come up with the with surgeons, and that is the market which used to introduce some substandard and adulterated product into the market. So therefore, there is a need to have a sensitive and innovative method for rapid and precise quantification of such API in the different formulations. So my work is related to the method development of this swine flu drug. So basically, we have been exploring the spectrophotometer, a simple spectrophotometer, which is a cost-effective technique you will find everywhere. So we have procured the formulation from different CM office, just like Tamiflu from the Solan CM office, and similarly Star Flu from the medical college, one of the medical college in Tanda, Kangra district, Himachal Pradesh, and got the standard for the calibration purpose from the CIPLA company. So we just explored the reaction characteristics of the API, that is the active pharmaceutical ingredient, which used to be present in such type of the formulation. So you can see from this structure that it contains the amine. So we have explored this purpose, this functional group for the purpose of quantifying the molecule in the given formulation. So we have treated this API with the carbon disulfide, which used to form the dithiocarbamate. You can see from this equation. So this can be further reacted with the suitable metal salt, just like copper acetate here, which used to produce a metal dithiocarbamate. So this is going to be very important because this used to be a colored species and can be quantified by exploring the spectrophotometer. So we have just put the basis of our method, this reaction, by exploring the functionality of the active ingredient which is present in such type of the swine flu drugs. So this is the spectra which we obtain when we have this reaction. We used to form the metal complex, and this is correspond to the metal dithiocarbamate, which used to exhibit the lambda max at 430 nanometers. So this is the yellow colored species. You can see here, very intense. So it used to have higher sensitivity because of the intense color formation. So later on, we just have the optimization of the condition for this reaction. So we have just carried out various solvents. So we come to the conclusion that the methanol is going to be much cleaner solvent for the whole process. And we have optimized the pH and the temperature and the metal reagent. We have been using certain other metals also, but we got the better results by exploring the copper acetate. So you can see the impact of the pH on the color stability, because stability of the color is very important for any spectrophotometric analysis. So it has been found that when it moves into the basic range, the color of the solution becomes more stable and give us static results. Similarly, we have studied the time effect, how the time has impacted the color intensity when you add certain moieties which is related to some basic compound. So it has been found that it is going to be stable up to the 90 minutes when you reacted the substance for the measurements. So it is going to be nearly stable for this duration. So this is also going to be important for this method. So this is the calibration graph which we obtain with the standard molecule. So this is how we can have the situation. Sorry. So this is the calibration graph. So after having these calibration graph, we're supposed to get certain optical characteristics of the method. So we used to obtain the linearity range under which we can apply certain drug analysis. It is around 40 to 60, 615 micrometer per liter. Similarly, the molar coefficient, that is the molar absorptivity coefficient for this reaction is higher, that is 10.4 into 10 raised to power 3. Similarly, you can see that if we look into the other optical characteristics and the comparative aspect with some other superior method, so it has been found that it is going to be a comparable even with the superior method, just like a spectrophotometric method, which has been reported in the literature. Being a cost-effective method, we can have the better limit of detection and limit of quantification by exploring this method. Although the other superior method has a little bit higher color stability, okay, there may be some other reason, but we used to have the color stability up to 90 minutes. That is more than sufficient to measurement for the time which can be consumed for the measurement aspect. So when we apply the same standardized condition for the formulations, so we have taken the different types of the drug, just like 50, 100 and 200 microgram per liter, and we apply the different formulation just like star flu and Tamiflu. So we obtain a very good recovery with the good standard deviation results. So we have validated on these lines. We used to get certain things that the method is going to be accurate one. It has a good precision. It is selective. Even a small amount of the substance can be analyzed by this one. And besides this, if you have some other impurities, which is basic in nature, so your method is not going to react with that one, but it is going to only analyze the Tamiflu drug. Okay, so similarly, the reactivity is going to be important, which impart an intense color, and because of that, the sensitivity of the method is comparatively low. You can see from this data, this figure, that how much it has a limit of quantification, and it has a good range, that is a good linearity range. And similar, the method used to be robust one and rugged one, because it is not going to change its result if you change slightly.
Dr. Chetan, please conclude.
Okay. So this is a cost-effective method which used to be there. If you compare with the mass spectrophotometer or HPLC or electrophoresis, so you can have this method analysis in your laboratory easily, because this is a cost-effective and time-effective procedure. So at the end, I would just like to conclude that we have the reliable, accurate, and sensitive and cost-effective methodology. Because of that, it is possible, because there is an instant color formation which leads to have this type of the method. And this can be even apply if you have some other impurity which is basic in nature. So you can apply up to lower level, and this method can be further extended to similar other formulation where we have the amine-based API in other drugs also. So this is what I have in my conclusion. So these are the references, and thank you very much for your time and patience. Thank you to all of you.
Sharma, and an assistant professor, and I'm working in the department University Institute of Biotechnology, University Center for R&D, Chandigarh University. And first of all, I would like to thanks to the organizing committee member of the conference for inviting me as a speaker. Now, let's start with my presentation is on bacterial nanocellulose in synergy with herbal extract, its production and characterization. Okay. So, sir, as the name suggests, bacterial nanocellulose, it is a cellulose that has been originated from bacteria. It is of bacterial origin. And the logic behind my work is that I have combined the bacterial nanocellulose with the natural properties of the herbal extract to develop different films that could be useful for different application, particularly the biomedical applications. So, bacterial nanocellulose, it's a nature's own super smart nanomaterial. It is a nanostructured exopolysaccharide of beta-D glucose secreted by different types of bacteria, particularly the Acetobacter species. And it is a pure form of cellulose. Why I'm saying it is pure? Because it lacks the lignin and hemicellulose that are present in the plant-based cellulose. So there is no need to purify it further. Okay. So it has various incredible properties like high absorbency, wet strength, inertness. It is biocompatible. It is biodegradable. It has high mechanical strength. And the cocktail of all these properties makes this material useful for the multitude of application. And its application could be in medical field, in food industry, and in textile industry, or in pulp and paper industry also. Okay, so but it has a large array of biomedical application. It can be used as an artificial scaffolding material. It can be used as implant. It can be used as a wound healing material. However, there are certain challenges also which is associated with the bacterial nanocellulose. The first challenge lies, the first snag is due to its high production cost. The next snag maybe is due to the based on the strain. Particularly, all the studies have been based on the conventional Acetobacter strain with the conventional HS media. That is costly issue, and there should be more studies on some consortia of the media. Okay, so the next challenge is the substrate based challenge. Only the most of the studies are based on the conventional media. So again, there is a need to develop bacterial nanocellulose by using some other cost-effective media, and ultimately lies the issues related to the clinical and marketing of the products based on the bacterial nanocellulose. So here, my study is focused on the fabrication of natural origin antibacterial nanocellulose film using bioextract for potential use in biomedical application. So this study has been undertaken to fulfill the following objective. Firstly, our objective is to prepare the low-cost bacterial nanocellulose from the fermented black tea broth media. Secondly, instead of using the conventional Acetobacter strain and the conventional media, we have used here the consortia of microorganisms, that is the symbiotic combination of bacteria and yeast. Then we have performed the production kinetics of the bacterial nanocellulose. Then we have modified this bacterial nanocellulose by the bioextracts from the therapeutic herbal plants like Tinospora cordifolia, neem, Arjuna, ashwagandha, and curry leaves. And finally, the physicochemical characterization was done. So earlier, there are various studies that have used different carbon sources and different strains of Acetobacter for it. And my objective is to find the cost-effective means of procuring the bacterial nanocellulose. So here, we have used the fermented black tea broth media. It has been used because this media can serve as a complete media due to the presence of vitamins and other supplements. And there has been already reports that it shows that that the black tea contains a lot of polyphenols, minerals, tannins, flavonoids that could impart various properties to the final product. Okay, so this is how the interplay of the bacteria and the yeast in the fermented black tea broth can direct the synthesis of bacterial nanocellulose. Okay, so the yeast partner in the consortia converts the glucose present in the media to ethanol, and this ethanol in turn is used by the acetic acid bacteria to convert the process to make the process towards the synthesis of the extracellular polysaccharide, that is the nanocellulose. So ultimately, it is the dynamic interplay of the yeast and the acetic acid bacteria partnership that contributes to the bacterial nanocellulose production. The methodology is firstly, the tea is brewed under the sterilized condition, and it is supplemented with glucose. Here, 60 gram per liter of glucose has been taken as an optimal concentration of glucose in 1 liter of the brewed tea, and then a small quantity of this Scooby culture, the symbiotic combination of bacteria and yeast was added to it. Then it is incubated for 20 days, and after 20 days, cellulose, the bacterial cellulose got synthesized at the air-liquid interface. This cellulose is harvested, and then it was the cellular debris and other things was other media component was removed from it by boiling it in 0.5 normality of normal NaOH, and then treating it with water, and then it is oven dried, and finally we can get a dried bacterial nanocellulose film. Okay, now this film have various incredible properties. It has high mechanical strength, but the one property that is lacking in this film is the antimicrobial nature. This film could be made antimicrobial by some natural means, and that is why I have taken the herbal extracts or the bioextracts from the herbal plant to make this film antibacterial. Okay, so After isolating this film, I have dipped it into various concentration of the bioextracts from the herbal plants of T. arjuna, ashwagandha, Zardica indica, T. cordifolia, and curry leaves. And then it was further tested for physicochemical characterization. So these are some results that is showing the bacterial nanocellulose production using the fermented black tea broth medium, as well as we have also used the used brewed tea, that is the tea part that we used to throw after making a tea. Okay, so the optimum sugar concentration that is to required is 60 gram per liter, and we have obtained a volumetric yield of 13.3 gram per liter and 12.8 gram per liter from the brewed tea respectively. The optimum pH is around 3 and the optimum temperature is around 30 degree. Next, the production kinetics of the BNC was also studied, and it was found that by using the fermented black, freshly brewed fermented black tea broth medium, the BNC productivity was 0.66 gram per liter per day, and the sugar consumption was 2.07. The residual sugar was 18.4. Okay, and we have also tested the yield by using the used tea, which is almost, which is slightly less than the yield we got previously. And then we have also used, evaluated the BNC production by using the conventional NCIM 2526 acetobacter strain and the conventional HS media. Here, although the residual sugar was 8 gram only, but the productivity was only 0.1% gram per liter per day. So the reason of the low residual sugar here is that of course the media has been converted to, some of the byproducts have been formed in the media like gluconic acid that has been detected by later by HPLC. Okay, so we have also calculated the microbial count from the BNC pellicle form as well as from the black tea broth medium, and we found that it contains different concentration of yeast and acetic acid bacteria at different concentrations. Now, the antibiotic susceptibility assay was done by for all these for all these modified BNC films. So it was found that the antibiotic susceptibility assay activity was highest for T. arjuna, showing the zone of inhibition of about 27 mm, and it was lowest for the curry leaf, showing the zone of inhibition of about 14 mm. Next is the antibacterial assessment. Bacteriostatic and bactericidal activity was evaluated, and it was shown that the inhibition zone was highest for T. arjunaria and lowest for the M. cogni, that is curry leaf. The reduction potential of bacterial population is also highest for the T. arjuna and is lowest for the curry leaf. And the same pattern is observed in case of when we have tested the bactericidal property, that is the killing efficiency of the BNC modified films. Next is the
include
yes, okay, sir. So the FSM's image shows that nanofibrous porous morphology of the films. This is the ATR FTR analysis. Water retention and moisture content is quite high, about 94%. So in the conclusion, I like to state that bacterial nanocellulose can be produced by one of the cheapest media, that is fermented black tea broth medium, and the all-natural antibacterial film can be made by modifying the bacterial nanocellulose using the bioextract. The volumetric yield in this case is about 13.3 gram per liter. Fermented black tea broth medium can be a low-cost medium and is useful for the industrial scale production of BNC. And of course, the mixed culture of microorganisms could be more beneficial than the single-use strain. And this is all about my study. And this is my publication in the year 2003. And I would like to acknowledge the Department of Science and Technology, Ministry of Science and Technology, New Delhi, for funding this research work. And my heartfelt thanks to all my colleagues and students who contributed towards this study. And I'm representing myself. If anyone like to collaborate, so I will be happy. This is my information, contact information. And with a thanks, I would like to state that nature have given us lot of natural things, but only there is a need to strike the right balance between the focus and the ability to demonstrate the maximum potential of the green material.
Thank you very much.
Thank you, sir.
I'm going to discuss about advancement in electrode materials for lithium-ion batteries, a comprehensive study. So my paper ID is 262. So in my presentation, I want to discuss about what is the lithium-ion batteries, working principle, and state-of-the-art materials, and different types of materials which was used as a cathode and anode, and different types of structures which was available. And finally, I want to conclude the seminar. So rechargeable lithium-ion batteries. If you can see that compared to all other batteries, there are several number of batteries are available in the literature. Lead-acid battery, nickel cadmium, nickel metal hydride, and lithium-ion batteries are there. Out of that, lithium-ion battery is having the advantages to all other batteries. Now we can see that they are having the lighter, high energy density, high voltage, and there is no memory effect and low self-discharge. And they have a long cycle life when compared to all other batteries. Now we can see here the gravimetric energy density, that is around 140 milli of the watt per kg whenever we consider for the lead-acid batteries. So these are some of the applications of lithium-ion batteries. That's why people are more interested in these batteries. So what exactly is happening in working principle? So here we can see that we have given some of the examples, say positive electrode. In the case of positive electrode or cathode material might be LiCO2, LiMn2O4 or LiFePO4, depending upon, or polyanionic compound. There are several compounds are available as a cathode materials in the literature, whereas in the case of anodes, graphite, silicon, and metal oxide, there are several types of compounds are there for anode types. So cell is constructed in the discharge stage during and on charging, lithium ions are deintercalated from the positive electrode and get deposited in the lithium metal, while equivalent number of electrons passes in the circuit. This can be easily visible through this. So similarly, discharge reverse the process where the lithium ion from the lithium metal reintercalated into the electrode forming the positive composition. So these are the state-of-the-art materials. So these are the materials which we are using it as a cathode materials. So there is a spinel structure, there was a polyanionic compounds, and also there was a vanadium oxides, layered structures, and also polyanionic. So all these are there in the side of positive electrode materials. Whereas in the case of negative side, or in the case of anode materials, these are the main components. Whether
your slide is not changing.
Yeah, now, sir.
Yeah, now it's working.
Okay, yes, sir. So this was and whereas in the case of anode side, these are the materials we can see that insertion type material, example Li4Ta5O12, whereas TiO2B and all. Whereas in the case of metal oxides, we can see the different types of metal oxides present, and also alloys. These are some of the materials which we are using it as a electrode materials in lithium-ion batteries. So I'll discuss here about the major parts of the framework structures available as a cathodes materials. Now here we can see that spinel structure. You can see that in all these structures, common point is there was a vacant sites are available in all these sites. So here also we can see that kind of vacant sites are available. Here also we can see the vacant sites. So this represents that whenever the vacant sites are there, so there is a possibility of insertion of lithium into the particular structure and can be come back from the structure without distracting that structure. So that will be more useful to increase the cycle life and the capacity of the material. So depending upon the different types of materials, in all these cases, common point is this one. And redox potentials. One of the important thing to choose is one is the structure, which is having the vacant site, which will allow the lithium, and it has to extract the lithium without destructing the structure. And another interesting point is redox couples. So wherever the redox couples are there, for example, in LiFePO4. So we have to make sure that iron +3 to +2 redox couple is fit into this vacant site, and it is giving the particular capacity. Here we can see the examples of voltage composition curves, cycling behaviors, and all these things we can see here. So now one by one I'll go with that. ReO3 is the interesting structure. In this case, generally, any metal oxides which are connected through the corners, we can call it as the ReO3 structure. When there was some kind of edge shearing is introduced into the structures, that we can call it as the shear ReO3 structures. So in our ReO3 structure, whenever the metal oxides are connected or MO6 octahedra are connected together in a corner sharing, they forms the vacant sites. Whereas in the case of shear ReO3 structures, what they can do is there is edge sharing. Because of this introduction of edge sharing into the shear ReO3 structure, it will stabilize the structure without destruction, and in another case, it will also produce some other kinds of vacant sites compared to the ReO3 structure. So literature says that ReO3 type phases are good host to lithium, whereas once we introduced a small shear into the ReO3 structure, that will give a more impact on that. So these are some of the examples which are available in the literature: TaO2B, VO2B, and Al and NBO4. These are excellent materials for reversible lithium insertion. They belongs to the shear ReO3. All the lithium sites are connected in all three directions, and fast lithium diffusion is possible in all these cases. Here you can see the examples. So once we prepared the nanowires, nanotubes, there was once the morphology has changed, or the size and shape of the materials have changed, there is a change in the capacity versus voltage and the amount of lithium insertion also. So finally, it affects the capacity, morphology, and the size always affects the capacity. So once we go from micro to nano, we'll observe a good capacity in this case. Whereas in the case of discharge capacity versus cycle number, now we can see that if you are trying at different C rates, so 1 C rate, 3 C rate, 8 C, 20 C rate, once if you are doing the charging very fastly, so there was a decrease in the discharge capacity. That also we can see.
Please conclude first.
Yes. These are structures of ReO3s and how to produce the shears into that. Because once we introduce the shearing into that, we can introduce that. So why we have studied all these have given. So in such a cases, what are the materials available? Tungsten UOBs are available. So these are the types of vacant sites which is possible with that. So you can see the type 2 cavity, type 3 cavity, type 6 cavity, depending upon how they are connected. Here we can see that how they are connected. So how we have prepared this material? These materials were prepared by the sol gel method. So these are the XRD patterns which confirms that, and these are the SEM pictures which shows the nano or micro size, and how we used to make the electrodes. These are the general fabrication methods. We'll take these electrode material, we'll coat some slurry on that, including the active material, what we want to make it as a cathode. So this is the cell preparation. So this is the FAGLAG unit, what we are going to test it in for electrochemical studies. And these are separator and electrodes. And these are the maintenance of that. Then the first discharge, you can see that here is the 233 and first charge is 2. So depending upon the type of material, so these will be varied based on the redox couples of tungsten and niobium here. So this XA2 XRD here confirms that after the cycling, what is happening in the material. It shows that even after several cycles, structure is retained. So that is the beauty of these structures. And cycling behavior, we can see at different C rate, there was a different structures. So these are some of the examples. The same structures are available even in titanium niobium case. So similar kind of pattern what we observed. Even structure is stable after several cycles. So it retains the structure. And so what else? This was all these are the same things. Another type of material what we have done is the polyanionic compounds. These are also different types of cavities available with a. Here we can see that they are built up by corner sharing of VO4 and MO4 tetrahedra, and they are connected to the FeO6 or TrO6 octahedra respectively. So now we can see that synthesis methods, what are the synthesis methods available? So we have done all these things with sol gel method. So in such a cases, in few of the cases, what we observed was there was a distraction of the material. So particularly,
please come to the conclusions.
Yes, sir. sir. So these were the materials, and in conclusion, what we want to tell is, so we have done with the different types of materials. What we discussed here was like ReO3 structures and also polyanionic compound and also PbO2 type structures. In few of the cases, they didn't work in the micro level, whereas we moved from micro to nano level. There was a tremendous increase in terms of lithium insertion, which finally leads to the good capacity, and also the cycle rate has improved a lot compared to the micro. Thank you all.
Have you gone through some magnesium doped batteries, as magnesium is diagonally opposite to the lithium in the periodic table?
Yes, sir. So
Yeah.
there was a bit difficulty in magnesium. What we used to see is lithium as the ionic size is less, whereas if we compare with the sodium and magnesium, ionic radius is very large. So that the fitting into the particular electrode material, it is not possible with the lithium. So we tried with the sodium in few of the compounds. So we observed that insertion rate was less in the sodium case, even in the magnesium case compared to the lithium case.
Okay. Good afternoon, everyone. Firstly, I would like to thanks to organizing committee for giving this opportunity for the giving invited talk on the second international conference on the recent trend in material science and device. My today's topic is synthesis and characterization of copper ceria nanofibers for catalytic reaction of water gas shift reaction. I am Dr. Dan Bahadur Pal from Department of Chemical Engineering, Harcourt Butler Technical University, Kanpur, Uttar Pradesh. So this is the content, table of content. The first is the fundamental of nanofibers, basics of ceria, what we have used as material, then objective of the work, the preparation of composite nanofibers, characterization of composite nanofiber and its application. First, we have discussed what is the nanofibers. Nanofibers are defined as the fiber with diameter of order of 100 nanometer, that is called the basically the nanofiber. Nanofiber exists as special properties because of the extremely high surface to weight ratio in the comparison with the conventional nanofiber. Nanofiber have unique characteristic of the high surface area to and high surface area to volume ratio. At the surface area volume ratio around the 1000 meter square per gram and high porosity. Because of this, we have used as the catalyst because the nanofiber have high surface area and the reaction are the surface property. The basic or the fundamentals regarding the different zero dimensions in that is called the nanoparticle. One dimension it means nanofibers what we have used, nanotubes also nanowire. These are the called two dimensional at the nanoscale and one dimensional at micro scale. That is why we say that it is one dimensional. In zero dimension, all dimension will be nanoscale. Similarly, second dimension, it means there will be one dimension at the nanoscale, rest will be micro scale. Examples are nano coating, nanofilms, nanolayers, and three dimensions dispersion of nanoparticles, bundles of wire, and nanotubes, as well as a multi nanolayers. It means in this case, all dimensions in the nanoscales. These are the fundamentals of the nanofibers. Why we use the cerium oxide or ceria? What is the basic feature? Because the cerium oxide, also known as the ceric oxide, and cerium oxide, cerium dioxide, the primary emerging application applied to cerium oxide material in the field of the catalyst, because the surfaces of ceria in its most stable fluoride phase are dominated by the lower energy. It means plane will be HKL value will be 111, which tend to exhibit the lower surface energy. The reaction most commonly catalyzed by the cerium 4 in the water gas shift reaction. Water gas shift reaction, generally the hydrogen of CO2 react to water. That convert CO react to water, that convert in CO2 and hence the hydrogen. Basic aim of this experiment. Because of that, we choose the material as copper and composite with the ceria. Now, what is the basic objective? The basic objective of the work is the preparation of the copper ceria composite nanofibers through electrospinning method. Then optimizing process parameter during the preparation of the composite nanofiber and characterization. Then catalytic activity of the particular sample. So this is the material, cerium nitrate, hexahydrate used as a cerium salt, and copper acetate monohydrate used as the copper salt. And we have used here the polyvinyl pyrrolidone as a polymer, as a template. These are, and we have also used the ethanol and glacial acetic acid. The primary fabrication of ceria and ceria nanofibers are the preparation of precursor and polymer solution. They are two parts. One is polymer solution, other is precursor solution. It means one have the PVP and one has the cerium oxide salt with water or distilled water or alcohol. Then electrospinning of salt gel solution. After the salt gel solution make, then we make the nanofiber through electrospinning method. Then calcination of composite nanofibers. Then we have used as a catalyst. So this is the ceria nanofiber. This is composite nanofiber. If you see the when you add the ceria with the alcohol and after stirring, that looking like the white gel. In case of composite, when we add the copper salt, then color will be changed accordingly. Here we have used in the experiment the 0.2 gram of copper acetate monohydrate and 0.434 gram of cerium nitrate. It means cerium salt. And then added here the drop wise acetic acid added into the PVP solution, polymer solution for the easy making sol gel solution. So this is the flow chart of the particular synthesis of the nanofibers. Here we make the polymer solution, that is PVP plus ethanol, and the amount will be taken 1.2 gram of PVP and in 8 ml of ethanol. And second is the cupric acetate, it means copper salt plus ceria salt added with the distilled water. And after some time, we make in single addition few drop of acetic acid in between, and then stirring it will be around 2 to 3 hours. Then this solution will be sol gel solution will be there. Then after we make the electrospinning. This is the electrospinning setup where we have applied the high voltage between needle tip and collector plate. Through that the nanofiber will be prepared. Here the applied voltage around 18 kilovolt and the stirring pump will be here at 1 to 100 ml per hour. But feed rate will be 1 ml per hour, and collector to tip distance we have taken 10 centimeter, and the needle gauge will be 20 gauge. That's the dia of the particular needle. So this is the physicochemical parameters. First is the concentration. We have optimized the composition of sol gel solution. It means 10% weight by volume PVP and 1 to 1 mole % cerium nitrate and copper acetate. Then molecular weight of the PUP, that is 1.3 into 10 power 6 kg per mole. Viscosity, we optimize the solvent around 59 centipoise. And the process parameter here, we have taken the applied voltage, that is, we have taken here 18 kV, and feed rate will be around 1 ml per hour. Through that, we have optimized, and collector to tip distance will be 10 centimeter. So after the calcination, after the preparation, we have characterized the sample. First, we have characterized the thermogravitic analysis. Why we are doing this? Because we need the through this the calcination temperature of particular fibers. So as per the TGA analysis, we see that the after 850 there will be in case of pure nanofiber no changes in the weight loss. It means after that there will be no loss in the weight of the particular nanofibers. In starting 200 to 400, 100 to 200 remove the moisture content, 200 to 400 remove the
Dr.
organic.
Dhanwadu, please
Yes, sir.
summarize your work, please.
Okay. Then same analysis for morphology of nanofiber, that will be the around 130 nanometer. This is the regarding also same. Then we have characterized the FTIR for functional group. So we have find the cerium oxide around 513 wave numbers. XRD analysis of that particular sample. Here we see the different HSKL value on the different composition of different structure of copper oxide, dioxide. This is the energy dispersive ADS analysis. It means the elemental analysis of the particular sample. There will be the C as per the figure. The carbon content is more in the both. One has 64% and 66%. Next, we have the BT surface area also. Characterize here the cerium
Please
oxide.
conclude, please conclude your work, please. Please conclude.
Okay. This is the catalytic acid study, and this is the activity and determine the also here the kinetic study. This is the comparative study, present work and past work. This is the conclusion. The catalytic activity of temperature 150. We have done the 150 to 400. As follow the order of activity, the 50% given the best result, and the pure Syria will given the worst result as per the study. So this is the regarding the, and thank you.